Okay, looks interesting. DNA, deoxyribose, adenine, cytosine, guanine, and thiamine. Do everything bad open? No, it's all good. Great, okay. So I just got this working. I should be able to save that. This is input. Import counter. Let's see. ACGT. Will this work? String. None type found. Oh, I see, I see. Wait, what the fuck is happening here? Oh, I need f.read line. Perfect, okay. Import counter, print, .join, map, c.get, ACTG, I think it was, ACGT. you go. Okay. Oh, okay. Cool. Looks pretty good. Polymer of nucleotide units. You mentioned that the omnipresent nucleic acid DNA is composed of a varied sequence of 4 bases. Yet a second nucleic acid exists alongside DNA in the chromatin. This molecule, which possesses different sugar, called ribose. Okay, RNA. You took exactly 1 course in bioinfo. I mean, I'm kind of thinking about 0 bio background. It's about where I'm at. That's not true. I actually have a pretty decent bio background. But it just seems fun, and I also, when it comes to like suffix automata and stuff, like I'm pretty weak at that. All things considered. I'm pretty good at like I'm okay at combinatorics. I'm pretty good at like math and DP and graphs and stuff, but string manip, I'm not really there. RNA was only contained in plant cells, DNA animal cells. Okay, what does RNA do? So RNA looks like it has a U, and DNA has a T, so I'm guessing I just replaced the T with a U here. Primary structure of DNA and RNA is so similar because the former serves as a blueprint for the creation of a special kind of RNA molecule called messenger RNA or mRNA. mRNA is created during RNA transcription, during which a strand of DNA is used. I see. So DNA is like the archive, and then RNA is kind of the living instantiation of it. In eukaryotes, DNA remains in the nucleus, while RNA can enter the far reaches of the cell to carry out DNA's instructions. Oh, interesting. Okay. So just replace T with U. Sounds pretty good. Counting DNA nucleotides. Did DNA analysis cool algos? String stuff is the easiest stuff, way easier than any math stuff you've done. Just when it gets to like suffix trees, you know what I mean? Honestly, even KNP kind of confuses me. I don't know what it is. I think it's that you kind of have to hold 2 things in your head at once. Like with the graph algorithm, if it's like some max flow thing, you have your source and your sink. Like I'm pretty good at, like even for something pretty complicated, being like, oh, okay, I see why exactly this repeated process would be optimal. But for like these kinds of things, when you're like, I have some string, and then I'm gonna like decompose different substrings at random points into a tree that's like also recursive, I start to get really confused. Like I think you just have to hold 2 simultaneous kind of images in your mind at once, or at least that's what I feel like I need to do, and I have a hard time with that. I did this too. That's tricky. I mean, that's the big one. Suffix tree is the big one. There's also like, I feel like KNP, even that for me, I've done it 100 times and I still kind of find that confusing. Oh, transcribing DNA to RNA. Okay, I'm gonna need to get a macro down for this. This is pretty pointless. It's just an algorithm, memorize it, I guess. True, yeah. Yeah, I mean, I guess that's kind of how it goes, right? Like, if there's some code forces problem, there's you don't know it. There's you've memorized it. And then there's you have full mastery. With segment trees or something, I feel like I'm here. Luckily, I just put in so much goddamn time. But I guess that's what you gotta do. You just gotta memorize it. But I just can't help but ask questions, you know? We got that, and then I think I can kind of just say s dot replace t with u, right? Looks pretty good. This is for school. Kinda. I'm thinking about... Oh, wait, what happened? Oh, I got it wrong. Replace T with U. G-A-U, G-G-A-A, C-U-U. G-A-U, G-G-A-A, C-U-U. That seems almost exactly the same. Huh. I mean, I didn't read this really closely at all. Maybe it's asking something different. No, that seems fine. Is this for school? I mean, short answer, no. I'm not taking a bioinfo class, but it's for the glory. It's for the pursuit of a higher code forces ranking. It also kind of is for school because I'm kind of gearing up to work in the medical industry for a bit, and I'm put in so much time to DSA and machine learning. I have a computer science background, so it seems kind of logical to me to go into biotech. That just makes the most sense. And bioinformatics surely is a good thing to know. I think a lot of it too is I'm thinking about going to grad school in probably a year or 2 years, and I don't know, I'd rather, yeah, code forces. There's me. It's this is what I usually do when I'm streaming. And then I began with leak code. Are you even competitive to the Russians? I'm up there. I'm up there with code forces. I do pretty decent. This one I got up to D, which of the 20 something thousand people, it's top 3,000 maybe. I think I could have figured this out if I had more time, but I had to go. I'm really good at what LeetCode asks you to do, which is just kind of know every job interview question ever and every data structure and algorithm that could be asked. I'm pretty good at that, but I have basically no math background whatsoever. So when it comes to this one, you had to prove some weird geometric thing. This takes me longer. Same with string manipulation stuff. So always got to shore up your weaknesses. It's interesting that this was wrong. I don't, is it that I had the space at the end? I think that might be what it is. I mean, let's see. So AAUACUUUGA. Oh, wait, what the fuck is my code doing? Wait, what? Oh, no. Oh, I was missing a line. And that's probably why. Maybe I didn't copy that. CGGCCCUU. CGGCCCTT. That seems right. There we go. I must have missed. These guys are like 140 IQ. That's the goal. Okay, looks good. String algos. I mean, maybe what I should be doing is just straight up reproving these proofs, because I'm very vibes based. Like, I'll look at some of these, like, what was the previous one? Oh yeah, this one. This was a really good one. This was interesting. Yeah, if you know basics about DNA, this stuff is super simple. This one was really interesting. It was, you have up to 40 batteries. You're trying to put 2 batteries into a flashlight. You don't know how many of the batteries work. You need to find the first 2 that work. You have to try at most n squared over a, which is the number that work, attempts at plugging them into your flashlight. And it's not as simple as just trying every 2. You have to actually like be pretty smart about it. I kind of figured this one out by, like, if you change like basically the distance between the number of batteries, you can kind of ensure that eventually you'll find the correct amount within a certain limit. So maybe I'm pretty good at, pretty good at math and proofs and stuff. Complementing a strand of DNA. Oh my god. Watson and Crick proposed the following structure for DNA. Made up of 2 strands running in opposite directions. Each base bonds to a base in the opposite strand. A always bonds with T, C always bonds with G. The complement of a base is the base to which it always bonds. So I'm guessing we're just swapping them. No, we're not. A with T, C with G, if you know the basics. I guess I'm like half actually trying to learn whatever chemistry is afoot. I like kind of care about that, but it's probably not that interesting to watch me just read 3 paragraphs. So the 2 strands are twisted together into a long spiral staircase structure called a double helix, because they dictate how the bases from different strands interact with each other. 1 and 2 above compose the secondary structure of DNA. 3 describes the 3-dimensional shape. Secondary structure. Okay. Huh, all right. The reverse complement of a DNA string S is the string S to the C formed by reversing the symbols of S, then taking the complement of each symbol. So GTCA becomes TGAC. So you're saying A goes to T, C goes to G, so this should start with an A and then be 2 C's. Okay, that's not bad at all. F stop reverse print that dot join map S. And we might as well just say reversed here. What do they call it? A pair? Tertiary structure, secondary complement. I'll call it complement. Complement equals A goes to T, C goes to G, G goes to C, and T goes to A. Map object not reversible. Fair enough. A, C, C, G, 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 T, 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 T. Yeah, it looks right. Key error \n. Okay, fair enough. Damn, they got me. That's, I don't know if I've ever run into that before. That's actually really odd. For real? It says \n? Huh. Oh, it's okay. It's because input usually goes until the \n, so you would never encounter that, but I specifically redefined it to read line. So it might have a \n. Okay. Wait, I want to make sure it has the right final thing. So TG, so that means it should end in CA. Okay, yeah. I didn't like remove the last character or anything. Wouldn't solve it this way. Well, I've got a history of like, on my YouTube channel, I mean, not that I got any views, but I used to be really into posting like one-liners for the dailies. So like, for example, like this. Monstrosity. This is a pretty difficult question. This is kind of historic. If you get this on a job interview, they did not want to hire you. But I've done these so much, you know, to keep the streak going, which I've kind of failed to do. But to keep it interesting for myself, I do it in one line. So I kind of like writing, like making a little game of writing succinct code if it's not like particularly challenging. Rabbits and recurrence relations. God, I need to make macros. I think recurrence just has one C. Yeah. Wascally wabbits. Good lord. Leonardo of Pisa, commonly known as Fibonacci. Okay, mathematical exercise. Okay, so I'm guessing it's about like rabbit reproductive habits. The population begins in the first month with a pair of newborn rabbits. Blah, 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 blah. After two rabbits mate, they produce one male and one female. The rabbits die. The rabbits never die or stop reproducing. Okay, I feel like I can see all that. 5 and 3. Interesting. Sequence is an ordered collection of objects. Blah, blah, blah. Recurrence relation is a way of defining the terms of a sequence. Okay, I don't care about any of this. The total number of rabbit pairs that will be present after n months if we begin with one pair, and in each generation, every pair of reproduction age rabbits produces a litter of k rabbit pairs. I see. So it's like a modified It's like a modified Fibonacci sequence. What numbers would have to be here for this to just straight up be a Fibonacci sequence? Every pair of reproduction age rabbits produces a litter of K rabbit pairs instead of only one pair. Well, if it produced one pair, wouldn't that just be 2 to the power of whatever? Right, because you have one pair. That would just become 2 pairs. Each of those would just become 4 pairs. Right? Am I missing something? So if you produce 3 rabbit pairs, it would just be like this plus 1. Why would this not be like 4 to the 5th? Oh, because there's I think I need to read it a little more closely. Let's see what we got. Oh, because I guess they take a month to grow up is the idea. Yeah, okay. That was kind of an important detail. So if they take a month to grow up, I guess you get the Fibonacci sequence, right? You say 1, 1, I mean, this just shows it, 1, 1, 2, 3, 5, 8. So therefore, if this was a 1, it would be the Fibonacci sequence. You'd get the 5th Fibonacci term. But here, what we would have is instead it would be 1, 1, and then it's going to be n plus 1, and then it goes from there. Okay. How large can it be? 40 and 5? Okay. Well, the easy thing would just be to say x and y is 1 and 1 for blank in range n minus 1. X is the 0th month, y is the 1st month. So you'd say x and y is equal to y and x times k plus 1. One and 4. 1 and 1, 1 and 4. That seems right. No. Hmm. 1, 3, 5, 11. This is the population of rabbits 2 months ago. Oh, I think it's just times K. Yeah, that's what it is. All right, whatever. Let's go with this. Interesting. Okay. Computing GC content. MSF equals -1. Counter. Looks good. Hey. Hmm. 6404. So 227. Hmm. 60919. 6091954. Counting point mutations. Two strings S and T, Hamming distance, the number of corresponding symbols that differ. Okay. Avortism. How's your week going? Just minimizing the number of point mutations separating two species because of the biological principle of parsimony. Okay. Cool. Could you do a favor? What's the favor? Mendel's first law. If you aren't busy right now. I'd be surprised if you were one of these weird bots asking me to look at art. After all this time, you'd be a real sleeper cell. Yeah, I can take a look. An array A of size n containing non-negative integers is called good if all the following conditions hold. A1 is A2, or it's 0. AN is AN minus 1, or it's 0. AI is AI minus 1 plus AI plus 1, or AI is 0. We need, less formally, we need all non-zero A at I to equal the sum of its adjacent elements. You can add one or subtract one from some element in A. Find the minimum operations to make A good. I have no DP knowledge, so please explain. Well, n is 2 times 10 to the 5th. So if this were DP, you would need your states. You always got to think about like your state space and your transition. Do you use Python or do you use C++? Because I can use either, like whatever's more eligible to you. Or legible to you. C++. So you kind of need like two things. You need like, what's your state space, right? And your state space is like all the questions you want to answer. You also, do you care about the explanation or do you just want me to try to do it? Is this like for some job interview or something? And then you need like your recurrence, which is like how each question relates, okay, cool, to other questions. So, and it's like, what is the actual, what are all the questions? And then also like, what are all the time, what's like the top, like with this, it's just like, what's the number? This is the most important thing. That's like what you really care about for the time complexity. With this, it's like, the time complexity of the transition, so it's going to be the recurrence times the state space. That's a really long-winded way of saying because n is 2 times 10 to the 5th, that means that we don't really have a lot of room. So if it's DP, we would need pretty much our state space to probably just be I. We're going to have something that's like DP at I, and then we have a little bit of wiggle room that's like DP, it's probably just going to be like DP at J, some function involving that. It could potentially be like DP at J, or I don't want to get too long-winded here, but it could be maybe like a logarithmic number of things that you're relating to, but it's probably going to be something like this. It's probably going to be DP at I minus 1 if it's DP, where F is some function. But for me, where my mind immediately goes to is, I mean, just in trying to wrap my head around the problem, it seems like you really have two options. 1.5 gigabytes, wow. I guess the first thing to notice is that if A1 was 0 and AN is 0, everything will be 0. So that's like by default, the worst you have is, I'm going to do this the way that I would do this. In fact, I think I'm going to copy my template here. We got that. So I'm saying fast input output, get the test cases. And then here I just have like, I'm going to have my little macros, but you know, you've probably watched me code in this. So like I can just say like input n. And then I can say like for I from 0 to n, input x, a at I equals x. And then I'll say like int a. And then I can say like vector int test from a to a plus n, print v test. I should see for all these, it's going to be the wrong answer, but whatever. Oops. Oof, okay. I've made this mistake before of like doing everything and then forgetting to log in, and then it destroys everything I did. I think I'm just glump 1 on here. Yeah, I guess so. So it should print a bunch of nonsense. Using namespace std. Damn, it doesn't like that. All right, well, I'm not gonna worry too much about the implementation right now. Oh, I'm in. Okay, thank God. That would suck. It should just print a bunch of. It should just print the input basically. Yeah. Okay. 0 and 5, 3 and 4. Okay, good. That's like the biggest hurdle for me, at least right now. Although I have no idea. Maybe this is like really difficult. I don't know. But the first thing I'm noticing is that A at 1, it seems like you're kind of saying like A at 1 is equal to A at 2 plus A at 0, which is like the 0 beyond the array. Or it itself is equal to 0. I'm kind of, I actually immediately have an idea. This is I'm just giving you my like general thought process. So we have this array, right? And I don't really know if this is the right way to put it, but I'm going to make a like, I'm going to make a without loss of generality argument and see where it takes me. So like without loss of generality, I mean like the way I see people use this is kind of like if you said, what's an example? If you said something that's like, okay, take an array. You have some sum of numbers, and then you say without loss of and then the question, let's say, is like max subset sum. One thing you could do is you could say without loss of generality, this is exactly the same question as because a subset does not depend in any way on order. This is the same question as if you sorted it. Because it's all the same elements, and then you just take the last few that are not negative, and that's going to be the answer. So like without loss of generality, people use that to just be like, just like rephrase it. So for me, I'm kind of wondering if there's a way to say, it's saying you have A1 here, and you have AN here, and A2, A3, AN minus 1, and you're saying this is either 0 or A2. Yeah, okay. I don't think it's, I think it's not fully going to be this, but I'll go through what I was thinking. and then this is going to be 0 or a n minus 1. Yeah. Okay, and the thing I was thinking is basically, if this is A2, you're kind of saying that's the same as everything else, because what's A at I? It's necessarily got to be A at I minus 1 plus A at I plus 1. Looks like A at I plus 1. A at I plus 1. And in a way, if this is 0, you're kind of just saying, okay, well, then the array started there, right? Like if A at 1 is 0, it's as if the array started here. If A at 1 is equal to A at 2, it's almost as if the array started here and you just had an A at 0, which was 0. Because then, like, this satisfies the I minus 1 plus I plus 1 thing. Right? Because you're like 0 plus A at 2 is equal to A at 2. So in my mind, really, you're kind of asking, like, how far out does the array extend? Hey, off to elliptical. So what my thought was there's no difference in a way between if this was 0 and if this was 0, but that's actually wrong because you do have the option to make something different here. But I do think you can surmise a couple things. First things first, if A at 1 is equal to 0 and A at n equals 0, then immediately everything between that is equal to 0. So the answer is just going to be the sum of the array. Like, how much does it cost to just make everything be 0? I'm guessing there's no negatives, right? No, okay. It can be any size from what I saw, so you're not going to run DP over this. How's it going, mister? It's going pretty good. Been doing some editorials said DP, so I thought it was. That probably is, yeah. I've been working on this, but Bortism brought up this question. I think what it's going to come down to, you can add or subtract, is that right? Yeah. Sorry if I stopped your other work. No, this is honestly more interesting. This was like proof of concept that I got my little Python environment working, and I mean, it is interesting to learn about it, but it's not exactly saying the most mind-blowing things here. Mendel's first law, it's probably the first thing here that I don't immediately recognize. And the code, I mean, is just like not anything. A at I is equal to A at I minus 1 plus... okay. Okay, or A at I equals 0. I forgot about that. Yeah, that actually does... I think it's going to come down to drawing rules. I think the first rule you could draw is to say if a at I is equal to a at I minus 1 plus a at I plus 1, I think this is just necessarily impossible if you have a subset of larger than 3 things that aren't 0, right? Because let's say you have 4 things. You'd say, okay, well then this is equal to this plus this, but this is equal to this plus this. So assuming nothing is negative, this is not possible because you're saying that this is greater than this, but also that this is greater than this. So that's just strictly impossible. Yeah. And then you've limited the question. You've I think like limited the question to something quite useful, which is everything can. Well, the only other option if this is less than 0, it doesn't. I'm imagining they're not. They're all non-negative to start. Oh, and they're not allowed to be negative. Okay, thank God. You didn't get the greater part. Okay, well, there's one exception. The one exception is if... No, it's not an exception. I'm saying if you have 4 elements that are all non-zero, so I'll denote that with like an X in your larger array, and then you have a bunch of zeros on either side, like that's, just we're looking at any instance of 4 non-negative numbers, non-zero numbers, or positive numbers, then you're saying, okay, well, this is greater than 0. So therefore, this number has to be this number plus something bigger than 0. So we can say, I guess I'll call them like, well, x1, x2, x3, and x4. So x3 is greater than x2 because x3 is equal to x2 plus x4, and x4, all x's are greater than 0. Yeah. And then also x2 is greater than x3. So that's a contradiction. Therefore, we cannot have 4 or more in a row. We can only have at most 3 in a row, which we could have x1, x2, x3. That's just x2 equals x1 plus x3. And then these are equal to whatever. Then I think you have something that's very workable, which is for every element, there's really 4 options. There's, for any x, you have it's equal to 0, it's equal to x, but right before it was a 0. It's equal to x, and the thing before it was something, and then the thing before that is 0, or finally 3 x's in a 0. So you can try one of 4 things, right? And then the question becomes, how do you optimize this? This is really simple, I would think. This doesn't really mess with the state space too much because we still have something that's going to be like dp at I at maybe... You got to be careful because you can't say what was the previous value. You would need to maybe say like how many values before this were not 0. So let's say at j. So this can be anywhere from 0 to 3. And 4 x's are impossible, yeah. And this time complexity still works. We just need a way to like test all of these in constant time, which is not actually super obvious to me because you can have all of these be whatever, but I think it's kind of fine. I'm gonna have to learn DP. I have no idea what a state space is. Oh, okay. Well, it's good that I wrote this out. I guess I'll revisit this after I kind of attempt this question. I'll like kind of say that because it is. I think it's one of these things where it's like pretty mind bending, but it does really help to have someone just say it in simple terms or like colloquial terms. I think it's not that bad, honestly. And I think actually you don't even really need dp at I at j. This might be like kind of confusing if you're like thinking about state spaces and stuff, but I think what you could do is basically just say, okay, dp at I is going to be, you're starting at I, all previous are 0, or the previous thing is 0. So for example, you could say, let's say our array is like, this is what we've decided, 0, 0, and now we're at here. And there's kind of a few options. There's either, okay, we'll just make this be 0, and then you're here. How much did you add to your score? You added X to your score to make that be 0. You had to remove everything. There's make this be whatever it's going to be, and then have this be whatever it's going to be, and then go to a 0, and then you're at the next thing. So it's like you're building out this partition, right? Or finally, there's also just have this be X, and then skip to the next thing. Or there's have this be X, have that be X, or have X, X, X. And then you're skipping to this dp at j. And the idea is that this saves quite a bit on space. You have 1.5 gigabytes, so I don't think that's ever going to be a problem in any world. But this kind of, I find this, not only is it more space efficient, but it's also a little bit simpler for me to think about. That's just starting at point I, when the previous is 0, try the 4 options. And then you're going to try one of 4 things, like have this be a 0, have this be a 0, this, or this. And then you would just have some function that like plugs in, like, okay, from here, here, and here, what's the best cost that you can get? And I think that's not that bad. I think you just like, I'll have to think about that. For 2 of them, it's not bad at all. For 2 of them, that's easy. If I'm going through, if you're saying, okay, I want to just make X go to 0, this is just going to cost. I'm going to say this is the action. The cost is just going to be X. If you're trying to just have X, the cost is going to be X at I plus 1. Because what you're really saying, if you said, okay, I'm starting here, and I want to make this be an X, but then not the next thing, and then I jump to here. And then this can be an X or a 0 or whatever. So the cost here is going to be X at I plus 1. If you say, okay, I want X, X, and really I should say, like, there's a 0 prior to this, you know? This is going to cost however much it costs to make these be the same, right? Because this needs to be that plus 0, and this needs to be that plus 0. So it'll just be like the absolute value of X at I minus X at I plus 1 plus X at I plus 2. Because you did have to set this to be 0 still. And then the final one is the only missing piece for me, which is how do you make this be the most efficient possible? My mind immediately goes to, you set one of these to not change and you center the other ones around it. I think it's not even that though. I think it's just you change this to be the sum of either of those. Right? Because no matter what you have, if you have like 1, 1, 5, this needs to go to a 6. You've added 5. you know, no matter how you change any of these, that's going to be the minimum amount of changes possible. It's just setting this to be that. And you could say, oh, well, now it's 1, 1, 0. That kind of gets away from it. I don't know, if you said like 2, 1, 7 or something, like how do you change this? Or if this was 2, 100, 7, it's just going to be 2 plus 7 is 9. It's always going to wind up being this. So the absolute value of x at I plus 1 minus x at I minus x at I plus 2 plus x at I plus 3, because you still had to set this to be 0. And then I should say plus dp at I plus 4, because you're saying I was here, and now I'm jumping to 1, 2, 3, 4 there. And then this is plus dp at I plus 3 plus dp at I plus 2 plus dp at I plus 1. Okay. And with that, I think, yeah, we're ready to just build something. So you're starting at the first number. You can always set that to be whatever you want. So I think the way to do this is actually going to be pretty simple. I'm just going to have like a recursive function. I don't really care. Hopefully there's not too many problems with CodeChef and that. I do need a cache, so I'll say, and I'm going to have these be long longs because it's going to fuck with it otherwise. Partitioning in matrix chain multiplication. Oh, was that the Q4 on the last weekly? Res is equal to... Oh, sorry, I think I'm thinking of the week before that. You're right, that was DigiTP. I did pretty good on that contest too. $127. Let's see, so it's going to take int I. That's really just it. That's all we need. dp of 0. And then I'll say fill in cache plus n, -1, cache at n equals 0. That's the cost if you reach the end. Auto dp. I don't really need cache at n equals 0. I can just say if I equals n, return 0 for, well, let's see, res equals if cache at I doesn't equal -1, return cache at I. Let's see, res equals a at I plus dp at I plus 1. You just say, okay, set this to 0 and skip it. Great. If something, this means there's at least this means you're before the last thing, right? So that means that the array at most ended there. So if there's something after you. Yeah, that should work out fine. If I is less than n minus 1, res is min of res and a at I plus 1 plus dp of I plus 2. Looks good. And then it's just going to be like 2 more of these. But I gotta add n and the function itself. Right, yeah. I is less than n minus 2. This means that there's this and the next thing. So res equals min res. And the absolute value of a at I and minus a at I plus 1, you got to set those to be the same, plus dp plus a at I plus 2 plus dp I plus 3 and dp. And then finally, if I is less than n minus 3, res is min res, the absolute value of a at I plus 1 minus a at I minus a at I plus 2 plus a at I plus 3, so that's a 0, plus dp I plus 4 and dp. Okay. Looks pretty good. What the fuck? Fill n, oh, I always make this mistake. This is for fill. Those are the 4 cases, right? I think those are the 4 cases. Okay, there's my input. Oh, I never output anything. Easy. Five 4 0 1 4, big number. 5 1 0 1 4. Three and 4. Yeah, 1 makes sense. I see. So the problem is actually, and this was sort of a worry I had, this isn't quite true. I think a really quick way around that is I think I could just add a 0 to the end of every array. But I'm not really sure if that would work super well. If I is less than n minus 1, here I'm saying set it to 0 and move on. Here I'm saying I could do something really janky. I could just say a at n equals 0. And then I just decrease all these by 1. That way what it's going to do is it's going to say, okay, you're reaching outside the bounds of the array. If what you wanted to do was have like 0x and then set this to 0, but this will always have been 0. That's like not, if someone put this in production code, they would be fired, but whatever. Shit. 0? That's not right. It should say this. This should say test right here. Okay, it does. said when I equals 1, the answer is 0. Which is right. If I were 1, that would mean the thing before this was 0, and this is the end of the array. So just don't do anything. When I is 0, it's 0, which is not true. So I need to look for dp of I plus 1. Right here, a at I. So am I not setting a at I? Oh, no, I'm an idiot. It's that I'm looking at test case 1 because it's 1 index. So this whole time I've been looking at the wrong thing. That's funny. Still wrong, but... Zero, 1, 0, 1, 2, 3 million. Okay, so it does come up with the right thing there. Now I actually do want to look at test case 1. Zero, 5. It's that you can't have a lone element. There has to be at least 2, right? Because if you had 0x0, I don't think it even matters where it is in the array. Like if this is in the center of the array, this is 0, this is 0. This either needs to be 0 or this plus this, so this necessarily needs to be 0. If you have 0xx0, then they can be the same. Or 0xxx0, then they can be the same, but you can't have 1. So I just need to get rid of that case. I actually want to double check though. So I said all that, and I said that works if it's in the center of the array. Does that work if it's on the edge of the array? Here, doesn't matter. Here, this either needs to be 0 or equal to that. And then that's going to be the same with that side. So yeah, that is true. 51014 looks good. Hopefully it's fast enough and also gets it right. Damn, wrong answer. Oh, I actually get to see it? That's new. One, 2, 1. That looks right to me. I don't know. What am I missing? It needs to be exactly equal to that. Okay. Yep. You're not in the contest, that's why. Okay, so not only was I wrong about this, I didn't think about this hard enough. Not only was I wrong about this, because 0 plus 0 is not x, so this can never happen. That's also true with this, if I'm not mistaken. Right? Like, this plus this is this. That's true. So that checks out. But I just completely neglected the fact that, like, 0 plus this is not this. So you can only have pairs of 2. It's either pairs of 2 or 0. Okay. So if you just get rid of that, what happens? I think you might be able to just get rid of that and it's fine. So this should now say 2, I think. It should say the 2 has to go to a 1 and the 1 has to go to a 0, or this 1 has to go to a 0. It doesn't really matter how you slice it. It's kind of impressive it didn't run into that with these test cases here. None of them were changed by allowing for this. Sigsa? What the fuck? Invalid memory reference or segmentation fault. And yet that works? Okay, yeah, I think I know. No, that doesn't work. What did I change? This is clearly stuff that... Oh, I'm an idiot. I copied the output. Okay, that's fine. Let's see. So no more that. No more that. There's only 2 things you ever can do. Five 1014. Looks good. Okay, attempt number 2. No, damn. Did I delete everything correctly? Unable to find the test case? What? Do I just not get to look at it? Yeah, this is what I'm used to with Code Chef. It's some sort of weird paywall thing. This just seems weird because it gave me the original test case, right? What? Alright, fuck that. Well, let me clean this up. 8n is 0. Maybe it's like some wraparound thing. No, because then that would have showed up here. This is the editorial. I think I know what it is. I think I know what it is, possibly. It's that, let's say you're at the end here, and what you're trying to do is that. But this is the end of the array. mine will work fine because it'll say, okay, do this, set that to 0. That's all fine, but then it will say, and then go to there. So I really want to say if I is greater than or equal to that. It's the only thing I can think of. I guess it'll just freak out and just go on. I don't know if that case happens. There we go. Okay. Well, the implementation left a bit to be desired. I really bumbled my way towards the solution, but there it is. It's like recursive DP, I guess. So the state space here is it's like, what question are you asking? And then what other questions are going to answer it? So maybe you could view like Dijkstra's or something. You could say this is arguably DP because you're saying like from here, what's the closest? This is going back to that like state space and recurrence thing, like how to think about these DP questions that's helpful. From here, what's the shortest path? Why was OXXXO wrong? OXXXO was wrong. It was just a dumb oversight. It was if you had like a whole big array, no matter where it is, this, we're saying, okay, this is some number, this is some number, and then this is the sum of these, right? Like that sounds good, but I actually just completely neglected the fact that, yeah, okay, that means that this is valid. But the problem is that for either side, this x has to be the sum of that and 0, right? So this necessarily needs to be the same as this, which itself needs to be greater than this because it's this plus this. And it goes for the other side too. Like this is that plus 0. So the only way this can ever work is if this was equal to this because it's that plus 0. So therefore the only thing that can ever happen is 2 x's in a row rather than 3 or 1. I just did not, I don't know why I didn't think about that very clearly. Oh, it's equal, but then x equals 2x. All right, I gotta take this call in a minute. But I'll finish my thought here and then call this person back. You could arguably say Dijkstra's is DP, right? Because you could say like what you're asking, your state for any given node is from this vertex U, what's the shortest path to X, like where I'm trying to go? And then what's the transition? Is go to any adjacent node, ask the same question. And then from anywhere else, then you're like, what's the thing? And then the base case is you're at X. And then the answer for that is 0. So similar, it's just kind of like how you find these questions to ask yourself. And then you find a way to answer it given similar questions. So here the question was like, from an index I onward, what's the best you can do? It's basically just like jump game almost. And then the transition is this like weird recurrence relation that we had to derive with all the kind of logical inconsistencies you have to point out. And that's where kind of the specificity of the problem often comes in. All right, I gotta call this person back though. Thanks for sending that my way though. It's an interesting one. See ya.